All right, guys, great job on your quiz yesterday. I will be releasing those scores today, and if you are interested in a retake, I will be posting about that. Today, I know that we've been in Chapter 5, but now we're actually going to move on to Chapter 6, and this is actually the only section in Chapter 6 that we are going to talk about. What's going to seem kind of crazy to you is we are going to be spending 4 days, the rest of this week, on one section. With that in mind, keep that in mind that normally we just spend like 1 day per section, and we're spending 4, which means there's a lot to go along with this section. So everything we're going to talk about today has to do with polygons and their angle sum. So sum means add all together. So we're going to talk about adding all together the angles of polygons. So what a polygon is a many-sided figure. So like a triangle is a polygon, a square is a polygon. It's just kind of like the generic term, like hexagons and octagons, decagons, they're all considered to be polygons. They all kind of get put into that little like chunk. So we're going to explore just for a hot second these different interior angle sums and relate it to kind of some other things we've already done. So we're going to kind of take into account how the number of sides of a polygon relates to the sum of the measures of its angles. So first thing it says to do here is draw a quadrilateral. A quadrilateral is a 4-sided figure. So I'm going to draw what looks like a rectangle. And then it says create one diagonal. So diagonals are when you connect a corner to a corner. And what I see here is when I took my quadrilateral, my 4-sided figure, and I drew a diagonal, I created, it says what did you form? I formed 2 triangles. And so if I had 4 sides, 4-sided figure, that gives me 2 triangles. Keep these things in mind. Just kind of keep that in the back of your head. Next thing it says draw a pentagon. So a pentagon is a 5-sided figure. My pentagons always end up looking like houses. So 1, 2, 3, 4, 5. 5 sides. 1, 2, 3, 4, 5. Then it says create 2 diagonals. So when you create a diagonal, you'd always draw from the same vertex. So 1, 2. And what I notice here is that if I had 5 sides, that makes 1, 2, 3 triangles. So the rest of this does have me draw other ones, but I am not going to be drawing all of those figures in just for the sake of time. So what we're going to do is we're going to flip this real quick. And we're going to discover and chat about the sum of these interior angle measures. So if I were a triangle has 3 sides. How many triangles does a triangle have? 1. And if I am a triangle, thinking back to what we've done in the past, triangles, the interior angles, or these angles inside of a triangle, add up to 360. So if I just have a triangle, they add up to 180. So if I am a triangle, the sum of the interior angles of a triangle are 180. You should already know that. If I'm a quadrilateral, that means it has 1, 2, 3, 4 sides. And if it's a quadrilateral, the number of triangles that it creates are 2. And I know that each of these triangles, these angles add up to 180, and these angles add up to 180. So 2 triangles gives me 360, because 2 times 180 is 360. If I am a pentagon, here's the picture of a pentagon. A pentagon has 1, 2, 3, 4, 5 sides. And we just did this on the previous page. It has 3 triangles. So each one of these triangles, though, the angle measures add up to 180. So 180, 180, 180. 3 times 180 is 540. Hopefully you're starting to see a little bit of a pattern here. A hexagon is a 6-sided figure. And when I draw in the diagonals, there are 1, 2, 3, 4 triangles. So to figure out what the sum would be, 4 triangles means 4 times 180, which is 720. So heptagon, octagon, nonagon, decagon, these are figures. Obviously, you can see that there's no picture drawn. You don't want to see me try to do that. You'd probably all make fun of me. But a heptagon has 7 sides, an octagon has 8 sides, a nonagon has 9 sides, and a decagon has 10 sides. You're going to need to make sure you know how many sides each one of these has. Now, what we've noticed here, if you look at the pattern, however many sides it has to number of triangles, sides to triangles, it looks like we're subtracting 2 each time. So if I have 7 sides, it means it has 5 triangles. 8 sides means it has 6, 9 sides means it has 7, 10 sides it has 8. And then to figure out the sum, you just take the number of triangles and multiply by 180. So notice we're not taking the number of sides times 180, we're taking the number of triangles. So thinking about this, here's your little formula for today. To figure out the interior angle sum of any polygon, you're going to take n, which stands for the number of sides, and we have to figure out how many triangles it has. So what we noticed is if we took the number of sides and subtracted 2, that gave us the number of triangles. So we're going to take n minus 2. This right here tells us the number of triangles, and all of the triangles add up to 180, so then you times by 180. So this is formula today that you will be using to find the sum. Today's assignment will go kind of quick because you're really just plugging into this formula. The main thing to remember though is that you have to do n minus 2 then times 180. So let's take a look at these examples right here. So if you have a 15gon, this means that this is a polygon. Gon means number of sides. So this is a 15-sided figure. To find the sum of the measures, I'm going to plug into this formula. N, or the number of sides, is 15. So I'm going to take 15 minus 2 times 180. A 15-sided figure has 13 triangles. So I take 13 times 180, and I find that the interior angles will add up to 2,340 degrees. That's all you're doing today. Trust me, it gets a little bit more difficult, but we've got to try this out first. I'm really just going to go through one more. I'll go through this one right here. A 36gon means that you have a 36-sided figure, so the number of sides is 36. We're going to plug into the formula. 36 minus 2 tells us that there are 34 triangles. So I'm going to take 34 times 180. It's a big number. Don't freak out on some of these today. You're going to get big numbers. The interior angles, or all of the angles inside of a 36-sided figure, would add up to 6,120 degrees. So today, like I said, you're going to be just plugging into this formula, n minus 2 times 180. You're going to be using this all week. Please make sure that you maybe write this down somewhere, have this handy. If you need a copy of these notes, make sure you stop by. We do have some good examples that we're going to be walking through and talking through. And like I said, we are spending the rest of this week on it. So please make sure that you stop in if you need some help or send me an email.